Welcome to another video. All right, so in this video we have a wave question, and we're looking at a question under refraction of light. Okay, now we know that refraction of light is the bending of light at the interface separating two material media having different velocities or index of refraction. All right, so what we have here is the speed of light in air. The speed of light in air is 3.0 times 10 raised to the power of 8 meters per second. And the speed of light in glass. So which means now we have the speed of light in air. So the first medium, okay, the first medium is a what? Glass. Now the second medium is what? Air. So which means light passes from glass into air. So which means the first material medium is the glass and the second material medium is what? Is air. All right, so we have a ray of monochromatic light in glass strikes the glass air boundary. So the boundary separating the glass and the air, all right, the light ray, okay, passing through the glass, okay, strikes the boundary separating the glass and the air at an angle of 80 degrees to the boundary. So which means the angle which the incident light makes with the glass or the boundary, okay, is 80 degrees. So we need the angle which the incident ray, okay, makes with the normal, okay, and that will give us the angle of incidence, because we know that angle of incidence is the angle between the normal ray and the what? Incident ray. So we want to calculate what is the angle made to the normal by the ray of light leaving the boundary. So which means the transmitted ray or the refracted ray or the bending ray of light, okay, which emerge, okay, at the boundary, okay, what angle does it make with the normal? So that's what we want to calculate here. All right, so to calculate the angle of refraction, so which means we want to what? We want to calculate angle of refraction, okay? So first of all, let's calculate the incident angle, okay? We have the incident angle. Now we have our incident angle to be 90 minus 80, and that will be what? 10 degrees, because that is the angle which the incident ray makes with the normal ray. Now we also have the angle of refraction, that is transmitted angle. It is also known as the transmitted angle. So the angle of refraction is unknown, so which means the angle, the bending ray, okay, at the after it enter into the second medium, so the angle which it makes with the normal is the what? Angle of refraction. So we want to find the angle of refraction. Now to be able to calculate the angle of refraction, we are going to make use of the Snell's law of refraction. Okay, so now Snell's law. When we talk about Snell's law of refraction, okay, Snell's law of refraction, we know that Snell's law of refraction, there are two laws, but this particular one, that is the one about the ratio of the sine of angle of incidence, okay, to the sine of angle of refraction is proportional to the what? To the reciprocal of the absolute index of refraction, okay, of medium 1 with respect to medium 2. So what does that mean? We're going to have the ratio of the sine of angle of incidence to the sine of angle of refraction to be equals to reciprocal of the absolute index of refraction of medium 1 with respect to what? Medium 2. So we're going to have this to be sine angle of incidence, okay, equals to, that's over what? Sine angle of refraction to be equals to n2 over what? n1. So we then have n1 sine angle of incidence, okay, to be equals to n2 sine angle of refraction, okay, sine angle of refraction. So that's sine angle of refraction, okay. Now, so in this case, so let's plug in the values that we are given. So we have the angle of incidence. The angle of incidence is 10 degrees. Okay, we are not given the angle of refraction. Now, what is the index of refraction in the first medium, which is glass? So the index of refraction of the first medium is the same as the index of refraction in glass. And because we know that the speed of light, okay, is inversely proportional to the index of refraction of a material. So which means index of refraction of a material will be what? Will be equals to the reciprocal. It's also proportional to the reciprocal of speed of light. So in this case, to be able to calculate index of refraction of a glass, so we have the speed of light in air all over the world, the speed of light in a glass. So the speed of light, the index of refraction in a glass will be equals to 3 times 10 raised to the power of 8, this value, divided by 2.0 times 10 raised to the power of 8. And this will be 1.5. So which means the refractive index of glass is 1.5. Then also we want to calculate the refractive index in air. You know, that is N2, that's air. So to calculate the refractive index in air, it will be speed of light in air divided by what? Divided by the speed of light in air, okay? And that will be 1.0. That will be 1.0. So we are going to plug in the values in this equation. We are going to plug them into this equation. So I'm going to bring down this equation, okay? I'm going to bring it down here, okay? So we have N1 sine theta 1 to be equals to N2 sine theta 2. N1 sine theta I index, that's angle of incidence, then angle of refraction. So plugging in the value of N1, N1 is 1.5, then sine angle of incidence, which is what? 10 degrees, okay, 10 degrees, multiplied by the index of refraction of the second material, which is 1, then multiply by angle of refraction. So to calculate the angle of refraction, so we know that sine of angle of refraction will be 1.5 multiplied by sine 10 degrees over what? Over 1.0, which is the index of refraction in the second medium. So what is 1.5 multiplied by sine 10 degrees? So that will be 0.2605. We have 0.2605. 0.2605. So we can now take the inverse sine of this value. So the sine of, now the angle of refraction will be the inverse sine of 0.2605, okay, sine inverse of 0.2605. So let's get what is sine inverse of 0.2605. That would be 15.1. That will be 15.1. And that is the angle made to the normal by the ray leaving the boundary. That is the line, the light ray leaving the boundary makes angle of 15 degrees to the normal. 15 degrees to the normal. Bye-bye. Thank you.